Okay, here we go. All is good with the world. So, no stream yesterday. I've hit my goals, apparently, on Google Fit, which is great. Okay, welcome to episode 19 of Writing a Little Interpreter in C++. Interpreter's called NHB. You know what? I wonder if the executable is called NHB. Yes, it is. This is the distracted already. Welcome back to episode 19 of Writing a Small Interpreter in C++. It's not a full stream in the sense that I don't do all the dev work on the stream, but I do probably at the moment 80% of it. Yesterday was one exception. I didn't feel like streaming or really talking that much, so I didn't stream. One of those days, children being ill, all sorts of fun stuff. The funny thing about one of the children, he likes to watch gaming on YouTube or Twitch when he's ill, so he lays there. And because I was around, I was like, no, that's keeping you awake. So I made him watch Jonathan Blow's programming stroke gaming streams, and he claimed he wasn't tired, but within 5 minutes of watching it, he was well gone. So, if you need your child to sleep when they're ill, then that's a good one to watch. I'm not sure what that says about him, or I guess he's not entertaining to 12-year-olds. Anyway, so yesterday, getting back on topic, I did do some coding. Turns out I got through a lot more what I expected. So where we'd left off was we'd got whatever we were working on beforehand, which I cannot remember what we were working on. I was talking about the interpreter stuff, the recursion, getting the recursion working in the bytecode interpreter. That's all now working. And the next big job was to get the error handling better. So we wanted to be able to write some tests that check the errors are being generated. Again, these were very minimal tests, and but whenever an error was generated, we were exiting the program. So what we needed to do was, let's go find the parser. Just get my hand on the keyboard, and then we can go a lot faster. There we go. Parser class. There we go. So there's a couple of ways you can handle errors. If you're in C++, the often taken route is to, when you hit an error, throw an exception. It gets you out of the deep, particularly if you've got handwriting your parser, so it's going to be recursive. Throw an exception, gets you out the exception, the call stack gets you back to a known good place, and you can log the error. That works. The problem is that you only get one parse error for each file that you're parsing, which, depending on the language, may be enough. But it's also useful to get 2 error messages, because then you can fix more than one, particularly when you're refactoring. So instead of doing that, we took the route that you would take in a language that doesn't have exceptions, and your parser has a panic mode. That means something's gone wrong, right? So a good example is we've got an expect function method, and we expect a certain type. Perhaps we expect an if statement or a closing right brace after some expression or something where they made a left brace. No, you want the right one. The trouble is, if you don't get it, previously here we would exit the program, we'd log an exit, which, not a bad strategy. Now we create a string using a interned formatted thing, so it takes the var args. Could do it with templates, I know, but I wanted to keep things compiling quick and simple. So we've got a var arg formatted thing, which basically uses svn print f to create the string, and then we put it onto our interned string set, so we know it's stored and deleted, and we don't have to worry about all that stuff. It comes back as an ID, and then we log it out. The important thing with logging is that goes up into here. If we're in panic mode, then we don't generate any more logs. That means we found something wrong, maybe in a function. Chances are if we find something else wrong, it's just an artifact of the fact that the first thing went wrong. It may not always be. So if we're already in panic mode, we return. We just carry on. In here, the expect would advance past the bad thing, or the good thing if it was correct, and just move on. And all is good with the world, sort of thing. But the first time we come in, we log the error message into at the moment, a global singleton. God, come on, I'm pressing the wrong button anyway. Which is just should be static vector of errors. Not the greatest way. I know if we get threading going, we'll have to do something better. Put the log message into the parser maybe, or who knows. We'll just see how it goes. As always, we do the minimum to get ourselves to the next step, and then we'll fix the problem. We're not a big code base. There's going to be no problems changing things when we need to. And I don't want to try and make it the perfect logger or the perfect parser, because I'll spend forever doing it, and I've been down in rabbit holes, and they're not productive in the sense of getting something working, which is the real goal of this. Well, we have something working now, so that's pretty cool. Red Bush tea today, or Rubush, and I shall maybe move to chamomile another time. I've got some caffeinated teas, but I dare not drink them when it's 9:19. Back on track. I don't drink them because I drink a whole pot, which is probably about a pint. It's in there. I probably shout that many times. I like my teapot, which is about cats called teapots. Lost track totally. So we could just never exit panic mode. We'd be like, ooh, we got a panic. Let's just get out of our recursion, return back out, and in main we got some really boring code. Did that do anything? No, because I'm in a different browser. We just got... Oh, look at that. I've got a bit of a mistake. You don't need to be there, because I've got an exit if errors there. And... exit if errors. And only if we so we have some boring code that effectively says, after we rolled it out to all places, check the number of errors. If we do, just return out. No. Some boring code which is in a macro, particularly this level, because we're probably going to have multiple things. But that is just quite literally, if num errors, display them, return failure, along with some wild horses and stuff to make your defines. Cool. Now that's a good strategy. We just come out, we're basically where we were before, just we're unwinding the stack now, but we're exiting. But we can do slightly better than that. So if we go into the parser, you will notice here, this is the global level, so we're hitting a function, we're parsing it, we're going back out, and then we're hitting another function, and so on. I switched the panic mode to false. So that means that we can do another run on another function. So maybe we found an error in main, but there's a helper function called foobar, we can go and parse that and see if that works. And we're like, yay! More error messages. All my messages you get, usually, if they're good, it means you can fix problems faster. If they're bad, it's just awful. Classic examples are, yes, well, there's many templatey style C++ errors that, fill up 2 or 3 pages of text, and you spend a while looking at them. They are trying to make headway on that, and that's part of what the concepts library is about, I believe. But anyway, so the important thing is that we now can generate more than one error. The celebrations, or whatever. The bad celebrations, so that was in the parser. As you may have just noticed, the type analysis also has it put in, so it can generate more and more messages. Messages aren't great yet, because nobody's writing any code, so nobody cares that much. Importantly, we can, improve them as and when we need to. We've basically got a line number and a type mismatch, so if you put everything on one line, you're not going to get very far. Now if I take you back to main, oops, go. You also see run error tests. No, let's zoom out a little bit so it looks a bit better. I'm going to say so the same idea as our run tests that should pass, which look a little bit badly formatted. Oh no, there are crazy things going on over there. Ceylon has decided, in its infinite wisdom, which I don't actually mind, to make these things look like a table. Which is great, because I normally format things like a table. Not necessarily great for these longer bits of code, but down here it looks a bit better. So, whoops, there we go. You'll see, at the moment, I just check the type of error coming out. You see sometimes we get 2 out, sometimes we get 1 out. And my error types are terrible. Currently we have a general type and a type check error. So pretty much did happen in the parser, or did happen in the type checker. There's text associated with it, so when you print it out you do get a bit more. But eventually we will want to make more of those. But again, we're sketching out the framework still, so this is a framework. It's proving that we've got an error message coming out, and we've got a type associated with it, so they can be the numbers. Like error, it's 4062. You forgot to put a semicolon on. That type of thing. Yeah. All that actually didn't take too long. Once I got the var printing, I was like, honestly, I was expecting to get bogged down in the parser for a week or 2. But it just didn't happen. It just went in smoothly, and almost too smoothly. I'm sure maybe there's something wrong, but we've got some tests. So. And in my head, I was thinking a week, maybe 2, to get the whole error checking working, a skeleton version of it. I was thinking, well, that's going to take up all of March, pretty much. Which leads me to where we are with things. I don't know, I hope that's coming through okay. Can't tell. Yes. So we have turned up compiler warnings. Again, none of this is aiming for perfection, we're just aiming to move it forward a little bit. I then went and fixed quite a few clang tidy suggestions, particularly the type. Your type might not be quite right, so I did a bit more work inside the bytecode machine. Improved printing of the bytecode, where we added numbers, and to be honest, that was all we needed at the moment. We had to do more, but incremental improvements. Testing, yes, we wrote some functional tests. Yes, we initially not error cases, but we did them in the end. Just going to use a function in main. No, we can add a big test system when we need to. Get error logging working. We did. Then write some tests for the error cases. We did. So that was my whole goal for March. Totally done it. I'm surprised. Also demonstrates how bad I am at estimating, or how bad programmers are in general. It could have, one thing I missed then would have been problems and could have overrun. So, as it is, we're now on to stretchy style goals and, well, stretchy bonus goals really. I actually did a run on the to-dos as well, but you know, maybe we'll do some more of those. I was talking about adding UTF-8. I'm struggling with. I'm struggling to see the value of doing that at the moment. When we add strings, we will definitely have to add UTF-8 string literals, because you know they are important. Well, he says definitely. We'll see. The strings are complicated. C or C style, you know, just having a char star, which is an ASCII string, is great. That easily goes into UTF-8 support by stepping. But how do you step through a string? You have to, you know, do you index it as an array of bytes, which would be wrong because UTF-8 can be up to 4 or 6 bytes. I know it could be 4. 4, let's go with 4 for now. Which is an awesome encoding, and well, worth a read if you're bored one day. Certainly the history of it's fun as well, and which I'm not going to try and elaborate because I'll probably get it wrong. So you know, we have to think about strings. You know, do we allow code points, or do we just say, you know, you're on your own, so we just provide a few next chars? I haven't decided. It would make sense for a string. If you had a string object, then you should be able to get the code points out of it. So you take your up to 4. I guess it is up to 4 because 5 or 6, and you get a UTF-32 out of it, an integer number basically, an unsigned integer number, which you can then use to do your various checks. The reason I'm struggling to see the value in it is because we're just not there yet. We haven't got enough types. We've got a lot of other things to add. I'm not about to start writing variable names with different encodings that are not ASCII. Although obviously nice to support it, but it feels like we should do a big hit on that at the time, and it's all in the Lexa, pretty much. After that, we're just dealing with intern strings, so it seems it should go in very smoothly. Variable names, and yeah, not worth it at the moment. So it would do if I was to release this. It's something I would do. So I've done a run on to-dos, and then not the most exciting thing to do. So I was thinking maybe add the not equals. That's a good one, and then maybe go for the adding a float type, probably F32, and you know, that should be good. Now, yeah, so let's do that tonight. Add a not equals, and probably a not at the same time if we haven't got one, which I don't think we do. So let's get going. First up, let's go to tokenize. And we're going to need to add a logical not, and a not equals. Now, with the power of compiler magic, we will get told some places where they're not. Even better if I can maybe This is what I want, but how do I get there? Not equals. Well, first of all, you should stay at the bottom. Equals. I just need to turn my phone up. Here we go. Power of magic. Good. So that's the only place we needed to do that. Now we have a match 2 going on. Because we want to not equals not equals. So those are in. I should say that I slipped out using hash defines and macros in C++. It's quite frowned on, but it's kind of nice. I don't use them at work, barely ever. They're not banned, but they're, you get code reviews and some people don't like them. But there's a certain amount of elegance to them. It's a real shame it's a text-based processing. It'd be great if they kept the simplicity of them, but moved it into a more sort of hygienic way, as they called it from the scheme places. So yeah, I kind of like them, but for meta programming, making your program generate the code, they are the simplest way. Loads of problems with them, obviously, but they really hit it there. Just like doom, yeah. I recall there was I think it was Sweet, but I'm not sure, for JavaScript, which was a sort of equivalent of macros, but they were hygienic and more Lisp scheme-like. Those were great as well. Not that I ever used them much, because I don't really do JavaScript. Right, that should have added it to Alexa. So, next up, parser. Not equal, logical not. Now logical not's probably going to have to take a full value, so I have to be careful with our type checker. Well, let's go to the parser. Ooh, I can't code like that, I'm sorry. I can talk like that. There you go. Maybe one more. That does look a bit small. Logical not is going to have the same precedence as equals, so minus, divide, may. So here we, not logical not, I mean not equals. Time. Oh, it was here. Pointless translations, but not equals and logical not. Now we build that. Woohoo! A gazillion warnings. Compiled bytecode. Okay, we're not really interested in those just yet. I am interested in those. Now, why don't I get... Here it is. Switch statements. Well done, but we really want you just at the bottom. Not entirely sure why. Okay. 543. 52. No, I'm not interested in those just yet. But great is telling me. Now, these are all multiple. Actually, I think logical not will go there as well for printing. Just fine. Good. So we added, you might not have even noticed, we added not equals. Where do we add it here? All we have to do is do the conversion into here, add it there. Now, I'm trying to think where we'd have a not. Would it be an atom? Not some expression, right? When in doubt. I took the decision to not think about this stuff and to use the Golang approach to it because those are pretty good. Operator precedence, or spelling precedence. Okay, so that's done actually tell me. Oh, no, sorry, no swearing on this channel. Arithmetic. Geoverflow. Oh, it's just a wonderful spec. Logical operators, cool. Plus not. Yeah, I think we're going to put it in the atom. U minus not. Well, I think nuts, but you did a. You don't want that to. Yeah. Maybe we'll change, but maybe we won't. So keyword if. Yeah, if is here. And then all are going to be somewhere else. Because they do have a bit better defined precedence. I'm not convinced I'm getting that right. Sorry, I'm googling off stream, aren't I? Oh, I found a nice table. Not. Of course, it's a Unity thing. Why am I doing it here? Brain is stupid. Unity operators, same precedence. I'm going to start that. Add it to my bookmarks. So, go. Unity. Yeah. They should have. Yes, we should make sure I get this associativity right. But anyway, yeah, cool. So when in doubt, if you're designing a language, Golang. Right, here we go. Else if, because it can occur around lex.kind. No, that's coming up my head without actually thinking. It was part of my brain saying stuff that is not related to what I was actually speaking about. But hey, logical not. Awesome, done. Right, some tests. Coolio. There we go. Where should we do next? Well, we've got to go to the type analysis. Zoom that back in a bit. We do that. Press F9. What are we going to get? Well, let's go check it actually builds. Initial filler symbol tables. More and more thinking. A default here. Okay, so we want you to really be next to the one Earth. Sometimes, sea lion, you make me wonder what you're doing. Right, so one done. In theory, you could have an if expression inside the logical not, or even the not equals. If expressions can return a value, but they also have curly braces, which means they have scopes of their own. Therefore, we need to call this guy. Right, what are we? Check types. False, assign. So definitely here. Equals, but just for your viewing pleasure, let's put that there. Now, a not is different. It's a unary, but we're not expecting a unary trait, we're expecting a logical trait. There we've got some. Okay, AST logical not. go. Now, I reckon we need... It'll check like that. Where were you? Where did you go? I can find you. Here. Nothing complicated like that. Type not equal to all type. Still no go back. Let's do that. That's a weird one. This isn't kind. About where did I can't paste that from? Some refactoring C-line style. Why would you do this C-line? Look at what a mess you've made. I obviously refactored error to error kind in my error module, and I wasn't paying attention. I'm not expecting you to do that. Look at it everywhere. Who's going to want to read error kind? Wasting my time. Is editable? I've taken the whole thing out. Lost where I was, which is even worse than actually going wrong. Where are we? Here we go. Are you not happy with that? Yeah, okay. Like tie. could be a function call, that is true. And then we just bomb out because again what are we to do? I'm not convinced that I've got this part of the error check can go. We don't have a panic mode in this error log, which we may need to do. We just push it back. Yeah, that's because it's that guy. But we may need a panic mode in this one as well to stop it spewing out spurious data. You see. Right. Oh, we've still got a few more warnings. Where are you? Calculate local variable slots. Now I reckon yeah, that is okay. That should do us there. Implicit fall through. Warnings are great. Now so we're halfway through adding these two entries. The next thing is interpreter. Now let's stop and think. What is logical not? It is flipping 1 to 0 and 0 to 1. Fairly well defined function. We will have to add a not or an I not instruction and compile to that. The logical not equals is just not logical things after applying an equals. So let's add a logical not first. So the not equals won't be an instruction to the bytecode, it will just synthesize into 2, it will synthesize into a equals and then notting it. But we will need to add the logical not function, which is cool. Right. I'm just thinking logical not. You also got bitwise knotting, which flips all of it on the number. So if we've got our compiler right, we should get some warnings now. Where's this compile to bytecode? Logical not's going to be a little bit boring, so just find unary plus, unary minus, AST kind, log. Compile the expression and then logical not it. Like we say, the greater than, so let's find equals. Here it is. And then we just do a, guess that's going to work. Yes. Yep. There you can see, or maybe not because I've zoomed in not enough, the whole Go. Synthesizing the logical not equals by doing equals, as I said, and then applying a logical not to it. So 2 instructions instead of 1, but minimising the number of instructions, and I'm kind of keen on that. Should this ever become a performance issue, we can optimise and create a bytecode for it, but we're not going to. So the only thing we now have left to do is probably see what the compiler says. Print. And there's that. And what else is complaining? Whoa! Well, what do you know? Let's find. No, remember we synthesized I minus out of that. Not trying to put the break in. And then push. If it equals 0, push 1, always push 0. Don't need that comment because that's no longer true. And we should have, what's this halt? Not. Cool. So if we now, oh, don't worry about that. Importantly, all the tests pass. So we're in the final run for adding these. Zoom out a little bit. No, not quite that far. Just make that return ball, and we should do not false. Let's get rid of that because that's an error. See what happens. Result is true. Not true. Ooh, general error, unexpected character. Did it, but false worked. No, false didn't work. That implies we did something wrong way back in the tokenized routines, and I think I know what I did. No. General error. Okay, let's have a quick look at the parser. Interested in you, interested in not. Advance. I didn't need any, I didn't. Didn't leave anything weird in there, did I? Nope. Well. Let's put a breakpoint. Move off the cursor. There's only one. Oh, come on. Paint mode is false. Paint mode is false. you go. That's what I missed. First of all, let's change that to logical not. Type check. Cool. This is what we've got assertions for. And that's going to tell me what logical not. Break. It should have been a return. What should it be returning? It's a boolean, isn't it? So C underscore ball type. Oh yeah, that reminds me, I've got these vectors in there that I don't like. Now if we look, no form parameters, the logical not. But it didn't exit. Here's a little bit of code our type checker should pick up. This should error. Type checker. Now, for now anyway. Turn XC1. True. XC0. Right, I'm good with that. One of the things I'm trying to be is very minimal on my tests. So, you know, I could run through putting a whole load of logical expressions in there, but I won't. I'm confident that we've already got logical expressions. As you could see, it went in as an expression. So 43 tests. Now, can I make it error? I'm not quite sure what. That should error, shouldn't it? It says yes, it did. This is a bit of a worrying one. I think I decided to leave it for another time. The reason I'm just keeping star of all the others. Where was I thinking? This, what I'm going to have eventually is the final expression is going to be implicitly returned, except if you try to do a return on a void function, then it obviously won't be implicitly returned. I mean, the void will cancel out and it won't try and return it because it says, nah, you're not got a void. You can see we've got quite a lot of type checking work to do, which I will pick off at some point. Right, I'm going to call that a night because that's quite a good bit of coding. Yeah. Yes, I'm quite happy with that. So, tonight we did a big review of what I'd done the previous night, demonstrating we've got quite a way. We've added a not equals and a logical not. They went in quite smoothly. And the joy of typed languages, if you set them up right, is that most of it I didn't need to think about. The final bit of thinking at the end, because I made a mistake and didn't return it, but mostly it was compiler driven. I added the type to the Lex. Well, actually, the tokenizer was pretty simple to do. It's a couple of lines. The parser, we had to type, and it complained. It said, you need to put them into the prints and all that stuff. That was all done for me, so I just could turn off my brain at that point. Thought about the precedence. My brain clearly wasn't working on that one, but we got it right in the end. Move on to the type analysis stuff, do a compile there, instantly saying you've got to put it here and here and here. Go in, it was, you could pattern match, oh well, the not equals is very similar to the equals, so therefore we could do that quite easy. The logical not was a bit more, well, not much. We just created a little bit of function that says, well, your type's got to be a ball because you can't do a logical not on anything else in this language. Obviously in C you can do it on integers. We may extend that in the future. Then we went to the bytecode. It was pretty simple. We knew we had to add a logical not, which flipped 0 to 1 and 1 to 0. It shouldn't, because of the type checker, you shouldn't have any other values, so maybe we can add an assertion in to the bytecode to say, you've either got to be a 1 or a 0 or something's gone wrong. Should we do that? So oops, val equals 1 or val equals 0. That's a constraint. We've done that. If that assertion fails, then something's gone wrong somewhere. Either the type checkers let something through, or who knows. Let's run our tests. And then we added, we rediscovered a thing we've been thinking about. Again, the interpreter was just add the type. Hey, you've got to do it here. And when we're compiling it, the compiled bytecode said, oh, you've got some missing AST bits, so add them in. We synthesized the not equals from the not and the equals, so we only had to add one new bytecode. Finally, we added it, the new bytecode, which is insanely simple. Not finally. Added a couple of tests, one for failing and a couple for passing. Passing, not parsing. And that was pretty much it. Enjoyable little bit of coding. Yeah. Well, I'm going to call it night there. What day are we on? Thursday, so unlikely to be streaming tomorrow, because I shall probably be making homemade pizzas, depending on whether the children want them. Bit of an experiment. We finally got I suppose, but I'll say we finally got the knack of making really thin pizza bases, and previously when we made pizzas that tended to be thick, and we didn't do it very often because they didn't come out great, but we can now make thin ones and they come out really nice. They all agreed that they were better than the shop ones we were buying, but not quite as good as Pizza Express, but we were getting there. Unfortunately, we didn't have any white flour, so you tend to have to make the dough apparently a good few hours before, so I made it tonight to eat tomorrow, so 24 hours before. You let the yeast do its thing, even though it's very thin, the yeast sort of seems to do something. I don't really know much about bread and dough. But we didn't have any white flour, so I made it with wholemeal, so it shall be a bit of an experiment to find out how it comes out. I'm not hopeful, and we have backup plans. But anyway, that is my evening tomorrow. Now possibly I'll resume streaming on Saturday, I'm not sure. If we do that, then we should be doing something probably along the lines of... Let's keep a list so I can do a review when we get to the end of March. I'm tempted to add a float type in. That'll give us another type. It will force us to to expand the type checker to more. Type checker's ugly. I'm perfectly fine with being ugly at the moment. We can do a big tidy up at some point. One thing is, another type in there. When I say char type, I may be thinking byte. I'm not keen on having the word char in there even. It's char's so nice, but yeah. Yeah, I don't know. We'll see. Because really what you do in the modern way of handling strings, you have a byte array and then you overlay onto that. Well, you effectively have a byte array that you can validate is UTF bytes, and then you can iterate through the UTF bytes using a code, returning code points. I believe they're code points, I have to check that. int32 values, but it means you can't random access your strings. You can random access the byte array, but it's not. If you do it randomly, you're not guaranteed to land on the beginning of a UTF-8 sequence. Yeah, and I don't go anywhere near UTF-16. We will not. I personally would not be doing anything with UTF-16. It's horrible. It works in some cases, and you've got the weird pairs that I can't remember the name of that I really don't like. Makes my brain hurt. So UTF-8 all the way. We could kill off all the other encodings. Obviously you still need to extract the UTF-8 character into a 32-bit value, but I prefer that over anything. I appreciate, I'm sure there's pros and cons, but we'll be UTF-8, as should everyone else, in my little opinion. And that is that. I would say, yeah, we're doing pretty good. If we can knock off a few of these this month, what I'd like to do is, I'm not sure, well, handling pointers are really interesting. There's lots of side effects on that. Not side effects, lots of preliminary things we need to do before we can handle pointers. We have to take out the dynamic allocation inside the stack of the interpreter. So I think what we'll end up doing is pre-allocating 10 megabytes, because 10 megabytes is nothing, but it is bigger than the standard stack you get on, certainly on Windows. I think it's only about a megabyte for your executable, which is extraordinarily small. We may even allocate 20. We may make that a priority, we may, who knows. But once we get pointers, then we can get to things like arrays and slices and all sorts of good things. And from that, then we can start having structures and maybe who knows what else. I don't want to. My goal isn't to make a super large language. I'd be happy with initially to begin with. Your basic types, support for arrays, support for structures, be able to allocate memory, so you can create dynamic arrays and all that sort of thing. From there, who knows, add some bindings to the CLib style functionality as a proof of concept, which will then let us start to actually write things in it. Some simple command line stuff. I really want to get to the point where I can write stuff. And once you can write stuff, you can see how the language is holding together. So if we put nothing controversial in it, get to a point where we can write things that aren't a factorial. We could probably write a Fibonacci sequence now as well. Isn't that awesome? But once we get to the point, we can output to files, we can read information in, we can read the command line args and do a few other things like that. I think we start to see how it holds together. And then I'm only going to very slowly add features. Then pretty much I'm going to only slowly add features with the exception that if the feature's in C, then it can go in, because C is, in my mind, one of the most minimal languages you can use. Even then, we're not going to add all of C in. It does some weirder things, but we're not going to do underscore generic, for instance, and we're not going anywhere near threading at the moment. That's all a long way off. I'm talking way too much. I don't like to predict what we're going to do, because that's usually an indication I run out of momentum, which we seem to be doing quite well with at the moment, so let's not jinx it. That will be probably the next stream, unless something happens and I decide to do it off stream. If I was going to do anything off, no, I probably would do that. And there we go. That is it. So I'm going to say good night, and this ends episode 19. Hopefully, you can. Hopefully, the quality is improving, but I don't know. I'm not naturally geared to doing this, so which is why I'm doing it, because you should do things you're not comfortable doing. And with that, I'm going to say good night. Right, thank you for watching, if you did watch. If you didn't watch, then you won't know I said thank you, so you can just be happy.